Hi, in this video we're going to use Google Spreadsheets to learn how to add, subtract, and multiply matrices. We'll also learn how to find the inverse and determinant of the matrices. So let's get started. Let's suppose we start by having a simple 2 by 2 matrix. We're going to use the cells within the spreadsheet as the matrix. So let's suppose the first number in the matrix is 2, the bottom one is 3, and the second column we have -1 and 7. So our matrix is a 2 by 2 matrix. Let's say in our second matrix we're going to have 4, 5, 0, -8. If we want to add these two matrices together, we have to simply set up the equation that adds each cell. So to do that, we are going to place our final matrix, the sum of the two, in any cell. I'm going to pick this cell. And this is going to equal this cell plus this cell, A1 plus D1, and press enter. Now, it might be a lot of work to go through all 4 cells and do that, but you don't need to. Again, you can just drag the formula over and it understands that it's going to add the cells adjacent. Drag it down and there's our answer. 2 plus 4 is 6, -1 plus 0 is -1, 3 plus 5 is 8, 7 plus -8 is -1. You can do the same thing if we wanted to subtract these. So this matrix over here will equal this cell minus this cell, A1 minus D1. And when you subtract two matrices, you're just subtracting the cell that's in the same spot in the corresponding matrix. I'm going to drag the formula over and down, and we should get similar answers. 2 minus 4 is -2, and so on. So adding and subtracting matrices is not quite any different from what we've already been doing. When it comes to multiplying, let's suppose we want to multiply the matrix now. And so let's say we want to multiply it by a scalar. So we want to take, let's say, this matrix and multiply it by a scale and scale it up by a factor of 2. So in this cell, it's going to equal 2 times that number. And once again, we want to scale the whole thing up by 2. So I'm going to drag this over, drag it down, and in all 4 cases, you can see the formula multiplied each number by 2. So that's to say 2 times this entire matrix is the same as multiplying each element in the matrix by 2. If we want to multiply two matrices together, let's suppose we want to multiply the first 2 matrices that we had. We want to multiply them together. There's a function for that. So right here I'm going to say the function, it's equals mmult. M-M-U-L-T. So that stands for matrix multiply. So again, you always start with an equal sign, and then you have to enter the arguments, which the arguments are what matrices do you want to multiply. So I'm going to highlight the first one, put a comma, highlight the second one, and then close parenthesis. And so there you go. This is the multiplication of these 2 matrices. Now you'll notice it's not the same when you multiply matrices. 2 times 4 is not 8. So it works a little bit differently, and it does that math in the background that you would expect. So that's multiplying 2 matrices. Let's say we have a matrix of 1 by 2. Let's say the number 4, -6. That's our first matrix. And the other matrix is 6, 5, 9, 8. I'm just making up numbers. So we want to multiply this matrix times this matrix. And so they have different amount of rows and columns, different size, but they can still be multiplied. So I'm going to, in this cell, say to equal m multiply, M-U-L-T, that, comma, that, the two matrix. And you'll see it's interesting that this matrix right here, the 4, -6, times this 2 by 2 matrix results in this value right here. Now what if I switch these around? Instead of saying 4 and -6 as a 1 by 2, what if I made it a 4 and -6 below it? And now this is a 2 by 1 matrix. If I were to try to multiply these together, a 1 by 2 times a 2 by 2, let's try it out. Equals m mult so I'm multiplying these two, and it gives an error. And that's because you cannot multiply a 2 by 1 by a 2 by 2. And that's something you'll learn in your book if you haven't already. So let me undo some of that work. And so now I'm back to where I was multiplying these two matrices together, the 1 by 2 times the 2 by 2. So the question is, can you reverse the order? Can we multiply a 2 by 2 times a 1 by 2? And if you tried it out, the answer would be no. So that's what's nice about using the spreadsheets, is it will tell you, it'll give you an error if you're doing it the wrong way. The next thing I want to show you is there's a very powerful tool in here, the inverse function. And it will give you the inverse of any one of these matrices. I'm going to go ahead and delete some of this. Let's suppose I want to find the inverse of this first matrix up here. So that's going to equal, you guessed it, M for matrix, inverse, open parenthesis, and all you do is highlight the matrix that you want to find the inverse of. And close parenthesis, press enter, and there's our inverse. We can also find the determinant of this matrix. And you can guess what that function is going to be. Equals m determ. I guess they try to abbreviate it a bit. M determ for determinant. Highlight this matrix, and that is the determinant. And so what it did was it multiplied the 2 times the 7, which is 14, and subtracted 3 times -1. So 14 minus -3 is 17. So this is really useful, especially when you have a 3 by 3 matrix. Let's try that out. Let's suppose we had some numbers. And we wanted to find the determinant of the 3 by 3. As you may know, finding the determinant for a 3 by 3 takes quite a bit more work if you do it by hand. But we can use this solver. And there is the determinant. So sometimes you need to find the determinant, and sometimes you need to find the inverse to solve some of these. The next thing I want to show you is how to solve matrix equations, matrices equations. So let's say we have the formula A times X equals B. A is a matrix and B is a matrix. And so what we're trying to fill out is, what does X have to be in order for A to multiply it to give you the B matrix? And so this can be a little more complicated than what you're used to with normal math. Usually you see a formula like this and divide both sides by A. X equals B divided by A. But you can't do that with matrices. Instead, what we're going to do is do the inverse function of A. The inverse matrice of A, I'm going to denote by doing A with a little apostrophe. And so anytime you want to move the A to the other side of the equation, you have to do the opposite of what it's currently doing. So in this case, before A times X, the opposite of multiplying is dividing. So that's what you can normally do. And when I say the word opposite, what I'm really the correct word would be inverse. The inverse of multiplying is dividing. And so the inverse of a matrix has its own set of math rules to follow. And we're going to use this spreadsheet to do it for us. So what we need to do is find the inverse of the matrix A. And you have to do that you have to multiply both sides by that inverse in order to cancel out the A's on the left-hand side. So when you do A inverse of A, it gets rid of that matrix right there. It's a lot like saying 7 times the inverse of 7. The inverse of 7 is 1/7. So 7 times the inverse should equal 1, right? So when we do the inverse of A times the original matrix, those will cancel out and give us a 1, and so that leaves us with just X on the left-hand side. You cannot only find the inverse, you cannot only multiply the left-hand side by the inverse A, but without doing that to the right-hand side. The other thing to note is when you find the inverse of A and multiply it on the left, notice I put it on the left-hand side of this A. You have to put it also on the left-hand side of the other side of the equal sign. Okay, so with that in mind, let's suppose we have a matrix that is of A for the numbers. Let me get rid of this. Let's suppose this is my A matrix. 2, 7, -1, -3. And let's suppose my B matrix is -7, -25. Okay, so my A matrix is on the left and my B matrix is on the right. What I need to do in order to solve this formula, A times some variable is equal to this matrix. This matrix times some variable is equal to this matrix. We've got to figure out what X needs to be in order for that to happen. So to do that, we need to find the inverse of this matrix. This is equal to M inverse of this matrix. So this is the inverse of the matrix above. And now I take that matrix and multiply it by B. This matrix right here is A inverse, and this one is B. And those are the ones I need to multiply. So let's do that. This is equal to M mult. Highlight the first inverted matrix, comma, the B matrix. And so here's our formula. Here's our matrix that x would have to be in order to get this equation to be true. So what this means is my original matrix up here, this is my A matrix. If I take this matrix and multiply it by my X matrix, the one I just solved for, I should get this B matrix as a result. So let's try this out to check our work. We're going to say this is equal to the A matrix. Oops, what did I forget? The M multiply. So the A matrix, comma, the X matrix. So the A matrix times the X matrix should be the B matrix. So this is one way to use the inverse functions to solve a matrix equation. Now, one last thing that is really useful is the transpose function. If you don't know what transpose is, let me show you that real quick because it is very useful. And so when you transpose a matrix, what you're doing is you're swapping the columns and the rows. So the columns become the rows and the rows become the columns. So all the x values become the y values and the y values kind of become the x values in a sense. We're switching the inputs and outputs. So to do that, we're going to use a function, equals, and the function is transpose, open parenthesis, and what do I want to transpose? Let's say I want to transpose this matrix up here, that matrix, A matrix. So I'm going to highlight that. And I'm going to transpose that matrix. So I do that, press enter, and look what happens. The 2 and the -1 were along the top. Now they're along the sides. So these column headings are now the rows. And notice down here, the 7 was the second row number. Now it is the second column number. And so that's how you can transpose. Let's try one more. Let's do a 3x3 matrix. Let's suppose our 3x3 looks like this. I'm going to transpose this data, swapping the columns and the rows. Highlight those. And now notice the 2, -1, and 15 are along the left, and and each row is now along the columns along the top. So that's how you transpose data. And that is it for this week. Thank you very much for listening.